Okay, so welcome everyone, and thank you, Marina, and everyone else. Um, I'm just like Marina said, I'm a fellow researcher at CNR, so at Institute for Heritage Science in Italy, and my main focus is on research and development on interactive 3D graphics, so real-time 3D graphics, and also everything that is related to online 3D, so Web 3D, as we will see today, and also Immersive VR. Okay, so these are my main research focus and areas. So today we're going to talk about briefly an introduction to this open source framework called ATON. But first, I just want to be sure everyone of you, of course, know these guys here. Probably you use them every day. So they are our web browser that we use to go through the internet and explore web pages online. So we are focusing today, especially on 3D presentation on the web. That's because in the recent years, as you noticed, there was an incredible amount of advancements in terms of 3D presentation. Yeah, I want to show you just an example here. I think every one of you knows already a Sketchfab platform. It's like the number one platform for publishing and consuming 3D 3D models online. As you can see from this video here, hope you are everyone is looking at correctly. Sorry, I have some maybe there is someone with the microphone. Okay, now it's better. Okay, so as you can see from the video, there have been a lot of advancement. Like in this case, as we saw here, there is some kind of advanced effects, like for refraction in this case. Everything that we are looking now at the moment is a web page. So there is no installation. There is nothing you have to install. So this is like a few examples on Sketchfab platform. So there have been a lot of advancements in this sense for publishing and presenting 3D models online to a standard web page using our browser. On the other hand, we have also a more tight integration of our web browser with devices. For instance, you already know that a normal web page today can access our microphone, our camera, on our laptops, and also smartphone, tablets, and on mobile devices. A web page can also access GPS, can access your device orientation, it can access your compass. So as you can see, there is a tighter and tighter integration with our web browsers. Especially important for us today is also another integration with the head-mounted displays. Because today standard web page can access also head-mounted displays and cardboards. So we are not talking about a specific brand, so like Oculus or a specific specific brand, but all head-mounted displays actually on the consumer market. So we are ranging from the low-cost cardboards up to high-end devices like Oculus Quest or HTC Vive. plus their controllers. So this is very important because you know, a simple web page can access a complex device like head-mounted displays, and this is possible because there was recent introduction of a standard called WebXR that basically unified both the immersive VR and immersive AR worlds. So that means that a web page can present into immersive VR mode, but also you can create augmented reality experiences without installing anything on your device. So you just have to open a web page, and that's it. And you can have an immersive experience, or you can also have an augmented reality experience. So this is now a standard. This is recent. We are talking about like from last year. This became an official standard.
WebXR.
So as we saw all these advancements here, it is clear that if we think about a web application, so just using a web page, they can become, especially for cultural heritage field, they can be an incredible opportunity, because if you think about it, we don't have to deal with different application store. So like as you already know, we have different stores, like the stores from Apple, Google store. We have also different stores from Oculus. So they are all different stores where you have to publish your application, and there is also often there are review processes that can be very prolonged. So you have to wait that there is an acceptance of your application. So you have to wait, and especially you have to install this application. So in this sense, web applications are becoming very appealing for digital heritage and also other fields, because actually they don't require the final user to install anything. Okay, so what you are needing is just a web browser. So this is a great opportunity for museums, of course, for institutions in general, laboratories, and also professionals, so single people that wanted to create some kind of web experience through a simple web page. Okay. So we saw that there is no installation. So of course, you can wonder, you may wonder, if there is no installation, where is actually located my web application, especially my content? So we are talking about like 3D models, audio, videos, and so on. So here we have just a simple 3 different scenarios that with colors. So if you look at the green color represents the physical location of our web application and its content. So 3D models, like I was saying, audio, and other description related to our experience through the web. While the blue color represents the device where we are consuming this experience. Okay. So on the left, the very basic case is that they match. So basically, you can imagine like a museum kiosk, for instance, or your laptop, and then you have the same, the web application and the content are on the same device that you are using to consume the experience. Okay, so this is the very basic case, and is offline, so you don't even need internet connection. You don't need any network connection. So this is the very basic setup. Okay. Then there is a second intermediate situation in which you can imagine a sort of hotspot, and people that are close by can consume the content. So like in this case, you can see there is this green dot that is, you know, like a sort of local Wi-Fi network, okay? And these people are consuming the experience on their own devices, okay? So without, like like we saw in the previous slides, there is no installation to do. You just have to open your browser and you can access some kind of interactive experience on your mobile phone or on your, for instance, your cardboard, head-mounted display on, and so on, okay? Then there is a third scenario that is maybe the most interesting. That's basically our content and web application come from another nation or even from the opposite side of the world. Okay, so this is very important because, as you can see, you know, the physical location can be very far away from us. And this is especially the case of our, like we have in our laboratory, a few servers that are, they can be reached worldwide. So that actually is the one that we are going to use today for some demonstrations, okay? Of course, there are also challenges for creating these web applications because it's not everything is so easy. Here I highlight 3 different challenges that we often encounter for this kind of presentation, interactive presentation of these experiences. The first one is, of course, the transmission. That means if you think about it, you can have very complex 3D models or complex content that you need to stream, okay, to the final user, to the final device, like in the previous two, in the last 2 scenarios that we saw in the previous slide. So this can be a challenge. A second challenge is related to the fact that web browsers are not so powerful. They have limited resources, especially the one that you have on your smartphone. So you have to be very careful on how you use your resources, especially for 3D, to present 3D models. So because you have to face this kind of potential problems, okay? And the third challenge is that sometimes is not so often discussed, but is crucial as well. It's basically that you have to face completely different interaction models. So, for instance, when you use your smartphone, okay, on your web browser on mobile phones, you use your fingers, okay? So you are used to some specific gestures like pinching, to zoom, panning, and so on. Then you have a completely different interaction model on, for instance, on your laptop, where you use your mouse, your keyboard. And then, of course, you have a completely different interaction model when you use head-mounted displays. As you already know from literature, they have their own guidelines, and is completely different from what we are used to do with mouse and keyboard. And also, we have to take into account that you have different profiles, different situations, because you may have a single cardboard. So you have some kind of interaction model, and then you have maybe a more advanced head-mounted display like an Oculus Quest, where you have one controller two controllers. So you may imagine, there are a very wide range of completely different interaction models that we have to face because they are different devices, and we have to provide some kind of interaction between all these different consuming scenarios. Okay. So that's why this is one of the reasons why we started developing this framework that is called ATON. So I want to share with you the official website, that is this one. So I'll try to share here on the chat. So this is the official website. As you can see here, there is you can find all the information about it's open source, of course, so you can have you can see here this is the GitHub. There is a documentation for developers. There is also an open group on Telegram, so you can join the group and stay updated with all the information about this framework. You can see here all the major features that are offered by the framework. And then you can see here some samples. We are going to see some samples live during the presentation, so we'll come back later. Then here you can see all the projects that are using the framework. So these are national and international projects that are using ATON framework. So this ranges from applied games to semantic inspection. We'll see more in detail all the use cases. And then at the end you can find also publications. So they can be useful for most of them are open access, so you can download and study them. So most of them are you can just download them and study them. So okay, so let's go back to the presentation. Okay, I hope you have also indeed opened the web page of the project. So as I was saying, it's completely open source, so everyone can use this framework. The main goal of the framework is that it enables you to create a liquid web application. What does it mean? It means that once you create your web application on using this framework, it basically automatically adapts to a wide range of devices automatically. So that means that if you create some kind of interactive experience, you can access such kind of experience or tool. As we'll see, also you can also create some tool for cultural heritage, and you can access them from mobile devices, so like smartphone, tablets, as well as desktop computers, laptops, museum kiosks, and then you can also use head-mounted displays. So all the challenges that we saw are basically automatically deal by the framework. So it automatically chooses the right interaction model for you. It's also quite easy to install, to deploy for institutions, for museums. And then very important is that this framework embraces all the recent web standards and open specifications for regarding the web. Sorry. So this is very important because it allows us to be interoperable with a lot of other tools and other other platforms that exist outside. Let's give you some examples of what we can create with the framework. These are just a few examples of what can be created using the framework. So of course, as you can imagine, we can create presentation of 3D museum collections. So for instance, statues and that you may present on a web page, and thus you can access you can consume and inspect these models like on smartphone and as well as head-mounted displays. We used the framework in previous projects to create applied games, so like for instance 3D puzzles. Like this is the case of one of the games created in collaboration with the Polytechnic of Turin in Italy. Then we have especially important for cultural heritage is the creation of multi-temporal exploration. So you have the same archaeological site or an object that you can explore at different periods. And we'll see this one more in detail later. Of course, for also related to the semantic inspection of these 3D scenes. You can use the framework to create also virtual tours. This is especially for static panoramas, but also video streaming videos, so 360 videos that you can access from every device. Then also very important, the framework supports automatically collaborative experiences. That means that you can access the same 3D scene together with other people at the same time. So this is very this is really opening a lot of incredible, amazing experiences together with other people. I hope to have to show you some examples later. And then you can also use the framework to create more professional tools for analysts. For instance, we created a lot of tools to inspect the sessions. So after a lot of people have interacted with our virtual environment, you have these tools that visually allow you to inspect what users have done, how they interacted, their attention, and so on. So as you can see from this slide, it can be used for several things. They are very different, and also with different target with different target users. Okay, so this is just to show you briefly what can be created using this this framework. So we were discussing about the standards, so and specification that we embrace. In this, there are a lot of standards, of course, but in this case, I just want to focus your attention on 3D formats for publishing. In the case of ATON framework, because we choose a format that is called GLTF. It was created by Kronos. And why is this so important? Because as you can see from this image here, is widely adopted. So that means that it is also easier to create 3D models using this standard. For instance, is already embraced by several 3D modeling software like Blender, 3D Studio Max. As you can see, there is a lot of already there is a lot of institutions and software, and the Sketchfab platform itself is using also the GLTF standard. So it's a standard that is designed for the web, actually. So its models are optimized to be consumed on the web. It also supports animations if you want to create some kind of nice animation for your models. As I was saying, it's very easy to create this kind of models using the standard, and they are also interoperable. Okay, so like for instance, as I was saying, the Sketchfab platform is using this exact same standard. So that means that the 3D models that you are using on ATON are all compatible with Sketchfab. So every model now on Sketchfab is compatible with the framework. So this is a very good news. And especially regarding this format, it's very important here to highlight the importance of the presentation of these models, 3D models, because this format here supports what's called physically based rendering. That means that it basically allows you to the rendering system to simulate complex materials. I will show you directly what this means on some quick demos, like this one, for instance. I hope you can see my screen. So this is one of the 3D models. This is actually comes from Sketchfab. Okay, so there is no just this is a opened. Can you hear me? Can you see the screen?
Yes.
Okay. So this is actually a model that I downloaded from Sketchfab. So there is no processing here. I just took the model, and we are presenting it on the ATON framework. As you can see here, there is very nice reflections here on the that simulate the ceramic material. We also have direct shadows here. I can move the light in real time. So this is just one example of what it means to embrace the standards. I have another example to simulate like some metals, like for instance this one. Okay, so this is a scroll. As you can see here, we have a very nice simulation of different physical properties. Like in this case, there is the simulation of gold here. Once again, this is a model that I just took from Sketchfab, and we are consuming it on the ATON framework. So it can be very nice to have a very complex simulation of materials. So this is crucial for, of course, for cultural heritage. If you imagine presenting like a 3D collection of a museum and so on. So this is important to have some kind of advanced presentation for materials. So now I want to quickly show you some basic features that are offered by ATON. There are a lot of them, of course, but today we're just focusing on just a few, especially those related to the multi-temporal topic. So let's first have a look at basic navigations. So I want to share with you a link on the chat, so you can wherever you are, you can just access this link. You can and you can interact together with me. So you should see something like this. Okay, this is a sample model, and in this case we are using a classic orbit control. So we are just moving our camera around our model. ATON offers you also navigation in first person, so you can use, if you click here, you can see that you can move in first person and explore first person our 3D scene. Then you have, of course, the immersive VR presentation that actually, in this case, it doesn't work because I don't have actually now connected head-mounted display. And also we have device orientation. That means that you can use your mobile device to be an automatically oriented device with the virtual camera. So you can use your mobile device actually to look around. Okay, this is a third possible navigation model. And then we have, as I was saying, the possibility to use the immersive VR or augmented reality navigation. Yeah, I just want to show you a video, because of course I don't have the possibility to show you that directly. This is what it looks like. This is the house of Cecilio Giocondo. This was one of the 3D models created by our laboratory in collaboration with Lund University. So as you can see here, this is a web page. Okay, so we have just opened a link, the same link, and it recognized that I have a head-mounted display, and I'm using my controller to move around and teleport in different locations. Okay, so very easy, and it automatically adapts to the device. Okay, as you saw during the video, there is also some sort of you know, here you can see here on our left wrist, there is also some buttons that you can use to enable some kind of other advanced features like measuring and so on. We'll see some examples later. Okay, let's move forward. Then we have viewpoints. So there is the possibility in your scene to define specific viewpoints. So I can show you, I can share with you another link. If you open this link, you should see a statue of Venus, and here on using these arrows here, you can move through different viewpoints. And as you can see, there is also different field of view that we are operating with. So it's very nice because we are moving to very smoothly between one viewpoint to another. And of course, we have a special viewpoint that is the home viewpoint. Okay. So this is just a basic, you know, bricks that ATON offers you for your web applications and your tools that you can use to create your experiences and your tools. Of course, the viewpoints are consistent with all the interaction models. That means that once you are you define your viewpoint, it is consistent when you if you call that viewpoint using head-mounted display. So the system automatically knows how to correctly handle viewpoints in immersive VR, because they are completely different, of course. But this is not worry for you. So it's just basically the system does this for you without you don't have to worry about how the system handles different viewpoints. Then I want to show you another interesting features regarding this is especially important, of course, for cultural heritage. There are annotations and measurements. And for this one, I want to share you another link that is this one here. So, and basically I'm sharing with you all links that are physically located in here in Italy. Okay, so you're basically accessing web application and content that are located here in close by, actually, here in Rome. So you should see something like this. Okay, so it's basically the same example that we saw before. But in this case, I want to show you the different kinds of semantic annotation that you can create using the framework. There are two different kinds. Is there a question? Sorry?
No, somebody wasn't muted.
Okay. So basically, you have two different kinds of annotations. One is, say, interactive, so you can create annotations inside the virtual environment. And the other one is that you have already created outside semantic shapes. I just want to show you very quickly how easy it is to annotate like this environment here. So I'm using actually my mouse at the moment. The very basic annotation here is a spherical one. So just in this case, I just want to show you very quickly how it works. So I'm just changing the radius here, and then I had like, for instance, one annotation that I call anvil. Okay, and that's a very basic annotation here that I created. This is a spherical, so there is a location and a radius for the annotation. But then I also can create more complex annotation that is called freeform. So I basically can do this and moving around model here and keep going here, and I'm just adding points on the surface, and I'm just creating a complex shape here. It's a semantic shape, of course. And then here I can call it like door, and I just created an annotation for the door. Okay, so this is very easy, and you can use your mouse, your fingers. On mobile device, you can also use pens. And Immersive VR, you can use your controllers. So it is very easy actually to create semantic annotations. It's very quick. And I also want to show you another possibility. Like, for instance, let's say this is another door. So let's say I do once again something similar. And here, okay. Let's see, I'm quite happy with this. And once again, I create, you can see here, I can choose once again door. And now if I select door, it automatically highlights the other door. Okay, so I just joined the two semantic shapes. So it's actually quite quick to create interactively, so user-driven, this kind of semantic shapes. We can also export these shapes. So let's say I created these two doors. I can also export, let's say in desktop format, so like OBJ format, and you can export these shapes, and basically you can reuse these shapes in other 3D software. So it can be useful depending on your workflow if you are a 3D modeler. Then I want to show you very quickly how to add measurements. It's actually very easy. You can use the M. If you want to replicate what I'm doing, you can use the M key. So let's say I want to add a measure here, like M, and then push another time, second time M. And you can see I just added a measurement here on the door. If you notice, if we can add another measure here, and I want to show you that it automatically scales also the unit that we are using. Yes, if you for annotation, sorry, you can use the help button here, and there are all the shortcuts. Okay, so here just wanted to show you how it automatically adapts the measure unit here. Like we are using here centimeters, and here is using meters. If you are on a bigger scale, of course, it will be showing you kilometers and so on. So it is smart enough to understand how to correctly show you measure units that make sense. Okay. They are also compliant with the immersive VR consumption. So that means that yes, it's possible to import annotations. Of course, today we do not have time to. Yes, yes, of course. You can use external 3D shapes. Okay, sorry, I'm just answering your questions. It is possible, of course, to import external shapes, as I was saying here, that are imported from other 3D software. Today, I'm just showing you just an overview of all these features. Of course, we don't have the time to go into too much into detail about this. The annotations and measure. I just want to show you an overview of all these capabilities. Okay. Okay, so I was saying that these shapes, this measurement, they are compliant with the immersive VR. So that means that if you are using a head-mounted display, you can see actual measurements inside when you are wearing head-mounted display. I have a video here that shows how it is when you wear an immersive VR device. Yeah, we are actually adding measurements in VR. Once again, this is a web page, okay? There is nothing that I installed here. This is an Oculus Quest head-mounted display. I just opened an URL, and I just can use my controller to add measurements. And as you can see, they are compliant with my the movements of my head. They are like floating labels that are inside the 3D space. Okay, so we can go forward. Just to show another important feature that is offered by the framework, that is layers. And you can we can open together this link here. I will share with you on the chat. Okay. Okay, so if you open this this link, this is another 3D scene. This is another case study developed by one of my colleague called Daniele Ferdani, in collaboration with the University of Louvain. Okay. In this case, I want to show you that you can actually you have multiple layers. So like just imagine like layers of the Photoshop layers. So you can show and hide different portions of your 3D scene. So in this case, I can show you that if I press the G key, you can choose here the 2D layer and reconstruction. The reconstruction is this semi-transparent model here. So you can actually switch off different layers. Okay, like in this case, we are hiding one of the layers, that is the reconstruction of this specific archaeological site. So as you can imagine, you can use this kind of features to create also multi-temporal presentations where you can use different buttons, for instance, and a completely different interface here to basically switch on and off different portions, or even move through time. Okay, as we will see in a while, how this can be exploited to have a multi-temporal environment. Okay, so they are just like small bricks that we are showing a very quick overview. So you can get you have an overview of what is offered by the framework. So now let's see how these basic features, very basic, they are just a small, just a small part of all the features that are offered by the framework. Once again, but let's see, especially for multi-temporal exploration inspection, how we can use this feature. So we are talking about, in this case, 4-dimensional, because we have 3-dimensional plus the dimension of time. So here I can show you two scenarios basically. One is more oriented to non-professionals. So you may imagine a broader public, general public, like for during expo or public exhibits. It is something that is very easy, is not targeting professionals. Okay. In this case, what we developed on top of this framework is called temporal lensing. This is one of the examples where you can see we basically created this sort of bubble that you can use to locally explore and discover a different layer, okay, in a specific location of the 3D environment. Like in this case, we are looking at the reconstruction of the Forum of Augustus in Rome, collaboration with the Treasure Market. Here is the Tomb of the Reliefs in Cerveteri. As you can see, it is very easy for a broader public to explore and have a quick peek into the past. Like in this case, once again, the house of Caecilius Jucundus. This is in Pompeii. We already saw that before. As you can see, you can use, in this case, your head-mounted display to discover the past in a specific location. This was very appreciated by the users because it's very easy to use, and so as I was saying, it's more oriented to a general public. And then we use this kind of interaction also for a public expo. The last year, this was before the pandemic. There were these two tablets with this kind of temporal bubble, okay, And if you remember at the beginning, we saw that we can use we can access like the microphone. Okay, so in this case we use the microphone to capture the sounds of the surrounding environment, and then use those sounds to I will show you once again. Use the sounds to shrink and enlarge this temporal bubble. So people could use these tablets using their fingers and their voice to interact with this temporal bubble. And the physical installation was not there. So it was not in Florence. In Florence, it was just the hardware, just these two tablets. And all the content and the web application itself were coming from Rome. Okay, so once again, there is no installation there. They were just just empty tablets with their own, just using the built-in web browser, okay, to create some kind of this kind of interactive experience for users. Then we have a second scenario that instead is also targeting multi-temporal exploration, but in this case is more targeting professionals. Okay, and for those of you that already saw the lecture from Emanuel Demetrescu, is working together with me on this tool specifically, and it's basically a tool for professionals to inspect four-dimensional environment that are semantically reached and with a formalism developed by my colleague Emanuel for keeping track of the reconstruction process. Okay, so in this case we are I will show you how it works very quickly. We started from we took the previous version of this tool that was a desktop application, and we basically recreated this application using the ATON framework. So now it's completely online. So now it's basically an URL that you can access and open on all web browsers, and it's actually developed under a European project called SHOCK. You can find this this project on the official webpage of the ATON framework, and also here I can share with you the link. This one. You can have a look here at this one. Okay, so this was the previous version that was a desktop tool, and then we just recreated the tool using the ATON framework, and now it's completely online. Okay, so you don't have to install anything. You just can click here and access the in this case is the working prototype that we are developing under this European project. So I will just show you very quickly how it works. So if you click here, okay, you can see once again this is a multi-temporal environment. As you can see here, the interface is different because this is another tool. It's another web application with a completely different interface, and we have here a timeline. So you can use the timeline to move through time. Okay. Okay. The time is up, so I'll just show you very quickly that you can. We are basically reusing the feature that I show you before in the previous slides. Like in this case, we are querying the semantic shapes here Each of these semantic shapes has information associated here. As you can see here on the top right, the stratigraphic unit here. And also another thing that I want to show you is the possibility to search. So let's say if I write here Anvil here, it is a live filter, so you can actually use the viewpoint features that we already saw to automatically adjust the camera in real time and focus on a specific semantic shapes or a group of shapes. Okay. And then, of course, we use the layers, so the one that we saw before, to switch between different periods. So we are basically, this is an excellent example of tool that is reusing and is exploiting all these features to create a completely different web application that is targeting, in this case, professionals, users. Okay, as you saw, there is a specific interface here, a completely different interface that is basically a sort of dress. Okay, so you have underneath all the functionalities offered by the ATON framework, and then on top you can use your own interface, because each one of these applications has its own requirements in terms of functionality that you want to expose. Like in this case, there is a QR code or full screen. In this case, there is a timeline. Okay, but this of course depends on specific tool or experience you want to create. Okay, so I just want you to close the presentation because the time is up, to just show you once again what it looks like to use this tool, but in Immersive VR, with using an Immersive VR device. As you can see here, we are querying all the semantic shapes in real time using, in this case, an Oculus Quest. Once again, we can inspect and extract information while we are exploring the space. Once again, it's a four-dimensional space because there is time and space that we are exploring. And it's dynamic because all the information that is that we are inspecting here comes from a graph database. So everything is dynamic. And we can, of course, explore the environment and move around the space. Okay, so once again, what we are looking here is not a tool that you have to install. You basically, it's a web page that you open, and you have all this kind of interaction right inside your web browser. Okay. Okay, so I think the time is up for the presentation. So just want to leave here useful links. Today was just a very quick overview or just a few features that are offered by the framework. It's completely open source, so you can use the framework in your projects as you like. There are on the official webpage you can find examples, projects that are using the framework. We are also creating a getting started, so you can have some step-by-step process to get started with the framework. As I said at the beginning, you can find several publications that are open access, so you can see more in detail for each project how we used all the features. Especially useful for you if you are interested. There is this Telegram group that you can join. Then in this slide there is also the official webpage of the MVic tool. This is basically one of the possible web applications that you can develop using the framework. And then if you want to contact me directly, you can use the mail. So I think I can stop here because the time is up.